Welcome friends. In this module we discuss more problems on binomial and negative binomial distributions. Let us revise binomial and negative binomial distributions. Binomial distribution. A random variable x is said to follow the binomial distribution with parameters n and p if it has the probability mass function f of x is equal to p of x equal to small x, that is equal to ncx p raised to x into q raised to n minus x for x is equal to 0, 1, 2, etc. n, where 0 less than p less than 1 and p plus q equal to 1, f of x equal to 0 elsewhere. Under the following situations, one can make use of binomial distribution. 1. The random experiment should have only two possible outcomes. 2. The probabilities of the possible outcomes remains unchanged from trial to trial. 3. The experiment could be repeated any finite number of times independently. 4. The variable of interest x is the number of times a favorable outcome happens out of the two possible outcomes when the experiment is repeated for n times. Negative binomial distribution. A random variable x with the probability mass function p of x equal to small x, that is equal to x plus r minus 1 c r minus 1 p raised to r into q raised to x for x is equal to 0, 1, 2, etc. and f of x is equal to otherwise is said to follow negative binomial distribution with the parameters r and p. Here x denotes the number of failures preceding the rth success in independent repetitions of an experiment with only two possible outcomes, success and failure, where p is the probability of success and let it assume to remain same from trial to trial, and q equal to 1 minus p is the probability of failure. In another form of negative binomial distribution called Pascal distribution, the variable y is considered as the number of trial required for the rth success in a sequence of independent trials with the two possible results, success and failure, where p and q remains same for all the trials. In such a form, p of y equal to small y, that is equal to y minus 1 c r minus 1 p raised to r into q raised to y minus r for y equal to r, r plus 1, r plus 2, etc. and equal to 0 otherwise. It is obvious that y equal to x plus r. Problem 1. 56% of all households of a city is having internet access. In a random sample of 10 households, what is the probability that exactly 5 households have internet access, fewer than 2 households have internet access, at least 4 households have internet access, the number of households having internet access is between 4 and 6 inclusive. Solution. Let x denote the number of households with internet access out of the 10 random samples. Probability of a household to have internet access is given as 0.56. Here x is a binomial random variable with parameters 10 and 0.56. Probability of exactly 5 household having internet access is equal to p of x equal to 5, that is equal to 10 c 5 0.6 raised to 5 into 0.44 raised to 10 minus 5, that is 252 into 0.0551 into 0.0165, that is equal to 0.2291. Probability of fewer than 2 households having internet access is equal to p of x less than 2, that is 10 c 0 0.56 raised to 0 into 0.44 raised to 10 minus 0 plus 10 c 1 into 0.56 raised to 1 into 0.44 raised to 10 minus 1, that is equal to 1 into 0.56 raised to 0 into 0.44 raised to 10 plus 10 into 0.56 into 0.44 raised to 9, that is equal to 1 into 0.0003 plus 10 into 0.56 into 0.0006, that is equal to 0.0037. Probability of at least 4 households having internet access, that is equal to P of x greater than or equal to 4, that is equal to 1 minus P of x less than 4, that is 1 minus of P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3, that is equal to 1 minus of 10C0 0.56 raised to 0 into 0.44 raised to 10 minus 0 plus 10C1 into 0.56 raised to 1 into 0.44 raised to 10 minus 1 plus 10C2 into 0.56 square into 0.44 raised to 10 minus 2 plus 10C3 into 0.56 cube into 0.44 raised to 10 minus 3, that is equal to 1 minus of 0.0003 plus 0.0034 plus 0.0198 plus 0.0674, that is 1 minus 0.0909, that is equal to 0.9091. Probability of households having internet access is between 4 and 6 inclusive equal to P of x equal to 4, 5, 6, that is 10C4 into 0.56 raised to 4 into 0.44 raised to 10 minus 4 plus 10C5 into 0.56 raised to 5 into 0.44 raised to 10 minus 5 plus 10C6 into 0.56 raised to 6 into 0.44 raised to 10 minus 6, that is 210 into 0.0983 into 0.0073 plus 252 into 0.0551 into 0.0165 plus 210 into 0.0308 into 0.0375, that is 0.1507 plus 0.2291 plus 0.2426, that is equal to 0.6224. Problem 2. Suppose an opinion poll of 12 randomly selected individuals is taken from a city where road development is proposed. 85% of the population supports the development plan. Let x is the number of individuals supporting the plan. Out of the randomly selected 12, find a P of x equal to 4, B P of x greater than 10, C P of 2 less than x less than 4. Solution. Here x follows binomial distribution with parameters 12 and 0.85. A. Probability of x equal to 4, that is equal to 12C4 into 0.85 raised to 4 into 0.15 raised to 12 minus 4, that is 495 into 0.5220 into 0.00000026, that is equal to 0.00007. B. Probability of x greater than 10, that is equal to P of x equal to 11 plus P of x equal to 12, that is 12C11 into 0.85 raised to 11 into 0.15 raised to 12 minus 11 plus 12C12 into 0.85 raised to 12 into 0.15 raised to 12 minus 12, that is 0.30114 plus 0.14224, that is equal to 0.4434. C. P of 2 less than x less than 4, that is equal to P of x equal to 3, that is equal to 12C3 into 0.85 raised to 3 into 0.15 raised to 12 minus 3, that is equal to 0.000005. Problem 3. An inspection of sources of drinking water in a town conducted by a voluntary organization found that 30% of the sources are polluted with coliform bacteria. In a random sample of 8 sources from this town, obtain the probability that A. No sources are polluted, B. At least 6 sources are polluted, C. At most 2 sources are polluted. Solution. Let X denote the total number of polluted sources out of the random sample of 8 sources. Probability of a polluted source is equal to 0.30. Hence, X follows binomial distribution with the parameters 8 and 0.30. Now, probability of no sources are polluted equal to P of X equal to 0, that is equal to 8C0, 0.30 raised to 0 into 0.70 raised to 8 minus 0, that is equal to 0.0576. Probability of at least 6 sources are polluted, that is equal to P of X greater than or equal to 6, that is P of X equal to 6 plus P of X equal to 7 plus P of X equal to 8, that is equal to 8C6 0.3 raised to 6 into 0.7 raised to 8 minus 6 plus 8C7 into 0.3 raised to 7 into 0.7 raised to 8 minus 7 plus 8C8 into 0.3 raised to 8 into 0.7 raised to 8 minus 8, that is 0.01 plus 0.0012 plus 0.000065, that is equal to 0.0113. Probability of at most 2 sources are polluted, that is equal to P of X less than or equal to 2, that is P of X equal to 0 plus P of X equal to 1 plus P of X equal to 2, that is 8C0 0.3 raised to 0 into 0.7 raised to 8 minus 0 plus 8C1 into 0.3 raised to 1 into 0.7 raised to 8 minus 1 plus 8C2 into 0.3 square into 0.7 raised to 8 minus 2, that is 0.0576 plus 0.1977 plus 0.2965, that is 0.5518. Problem 4. An examination with 16 multiple choice questions having 4 choices, out of which one is right, is conducted. What score should be set as the passing score such that the probability of passing a student who guesses on every question is less than 0.05? Solution. Out of 16 questions, let X denote the right answered questions. If the students guess the answer for a question with 4 choices, the probability for getting the right answer is 1 by 4. Then X follows binomial distribution with parameters 16 and 1 by 4. To find the passing score such that the probability of passing a student who guesses on every question is less than 0.05, that is to find the minimum value of X such that P of X greater than or equal to X less than 0.05. Here P of X greater than or equal to 7 equal to 0.0796. P of X greater than or equal to 8 equal to 0.0271. Hence, the minimum value of X such that P of X greater than or equal to X less than 0.05 is 8. Therefore, the passing score such that the probability of passing a student who guesses on every question is less than 0.05 is 8. Problem 5. If X is a random variable with mean 5 and variance 2.5, find one P of X greater than or equal to 2 mod of X. Solution. If X follows binomial distribution with parameters n and p, mean equal to n into p and variance is equal to n into p into q. Given n into p equal to 5, and n into p into q equal to 2.5. NPQ divided by NP equal to 2.5 divided by 5, that is equal to 1 by 2. This gives Q equal to 1 by 2. When Q equal to 1 by 2, P equal to 1 minus 1 by 2, that is equal to 1 by 2, that is equal to 0.5. Hence, n by 2 equal to 5 and we get n equal to 10. P of x greater than or equal to 2, that is equal to 1 minus P of x less than 2. That is 1 minus of P of x equal to 0 plus P of x equal to 1. That is 1 minus of 10 C0, 0.5 raised to 0 into 0.5 raised to 10 minus 0 plus 10 C1, 0.5 raised to 1 into 0.5 raised to 10 minus 1. That is equal to 1 minus of 0.000977 plus 0.00977. That is equal to 0.998926. Next, here n plus 1 into p equal to 10 plus 1 into 0.5, that is equal to 5.5. Then mod of x is the integer part of n plus 1 into p, that is equal to 5. Problem 6. 6 balanced dice are thrown 729 times. How many times do you expect at least 4 dice to show the sides with the numbers 4 or 5? Solution. Let x denote the number of dice showing the sides 4 or 5 out of the 6 balanced dice thrown. Possible values of x are 0, 1, 2, 3, 4, 5 and 6. Out of the 6 dice, probability of a dice to show the side 4 or 5 is 2 by 6, that is 1 by 3. Then x is a binomial random variable with the parameters 6 and 1 by 3. In a toss of 6 dice, probability of at least 4 dice to show the side 4 or 5 is P of x greater than or equal to 4. That is equal to 6C4 into 1 by 3 raised to 4 into 2 by 3 raised to 6 minus 4 plus 6C5 into 1 by 3 raised to 5 into 2 by 3 raised to 6 minus 5 plus 6C6 into 1 by 3 raised to 6 into 2 by 3 raised to 6 minus 6. That is 15 into 1 by 81 into 4 by 9 plus 6 into 1 by 243 into 2 by 3 plus 1 plus 1 by 729 into 1, that is 73 divided by 729. Hence, the expected number of trials with at least 4 dice to show the sides with the numbers 4 or 5 is equal to 729 into P of x greater than or equal to 4. That is equal to 729 into 73 divided by 729, that is equal to 73. Problem 7. The probability of a bomb to hit the target is 0.7. Find the probability that out of 5 bombings, exactly 3 bombs will hit the target. At least 1 bomb will hit the target. Solution. Let x be the variable denoting the total number of bombs out of 5 hitting the target. Probability of 1 bomb to hit the target is 0.7. Hence, x is a binomial random variable with parameters 5 and 0.7. Probability of exactly 3 bombs will hit the target equal to P of x equal to 3, that is 5C3 into 0.7 cube into 0.3 raised to 5 minus 3, that is equal to 10 into 0.7 cube into 0.3 raised to 5 minus 3, that is 0.3087. Probability of at least 1 bomb will hit the target equal to P of x greater than or equal to 1, that is equal to 1 minus P of x less than 1, that is equal to 1 minus probability of x equal to 0, that is 1 minus 5C0 0.7 raised to 0 into 0.3 raised to 5, that is 0.9976. Problem 8. Find the maximum n such that the probability of getting no tail in tossing a fair coin n times is greater than 0.05. Solution. Let x denote total number of tails out of n tosses of a fair coin. Since the coin is fair, probability of tail in a toss that is equal to p, that is equal to 1 by 2. X follows binomial distribution with the parameters n and 1 by 2. To find the maximum value of n such that p of x equal to 0 greater than 0.05. That is, to find maximum value of n such that n c 0, 1 by 2 raised to 0 into 1 by 2 raised to n greater than 0.05, or 1 by 2 raised to n greater than 0.05. For n equal to 1, p of x equal to 0, that is equal to 1 by 2 raised to 1, that is equal to 0.5. For n equal to 2, p of x equal to 0 equal to 1 by 2 square, that is equal to 0.25. For n equal to 3, p of x equal to 0 equal to 1 by 2 cube, that is 0.125. For n equal to 4, p of x equal to 0 is 1 by 2 raised to 4, that is equal to 0.0625. And for n equal to 5, p of x equal to 0 equal to 1 by 2 raised to 5, that is equal to 0.03125. This gives the maximum value of n such that p of x equal to 0 greater than 0.05 is 4. Problem 9. One man continues shooting at the target until he hits the target 6 times. The probability that he hits the target on any shoot is 0.4. Calculate the probability that he will have to shoot 10 times. Solution. Total number of hits to be achieved is fixed as 6. Probability that he hits the target on any shoot is p, that is equal to 0.4. Let x denote the number of failures preceding the rth success. If x failures are there before rth success, the number of trial equal to x plus r. Given x plus r equal to 10. Now to find p of x is equal to 4. Here x follows negative binomial distribution with Pm of p of x is equal to small x, that is equal to x plus r minus 1 c r minus 1 p raised to r into q raised to x for x equal to 0, 1, 2 etc. and equal to 0 otherwise. Hence, p of x equal to 4, that is 10 minus 1 c 6 minus 1, 0.4 raised to 6 in 0.6 raised to 4. That is equal to 0.0669. Problem 10. If the probability that a person will believe a rumor is 0.6, find the probability that the 10th person to hear the rumor will be the 3rd person to believe. Solution. Total number of 10 persons heard the rumor. Probability that a person not to believe rumor p equal to 1 minus 0.4, that is 0.6. Let x denote the number of person not believing the rumor preceding the 10th person believing the rumor. For 10th person believing the rumor to be the 3rd man believing the rumor, 7 people preceding the 10th person didn't believe the rumor. Here x is equal to 7, x plus r is equal to 10. Here x follows negative binomial distribution with Pm of p of x is equal to small x, that is equal to x plus r minus 1 c r minus 1 p raised to r into q raised to x for x is equal to 0, 1, 2 etc. and equal to 0 otherwise. Hence, p of x is equal to 7, that is 10 minus 1 c 3 minus 1, 0.6 cube into 0.4 raised to 7, that is 0.0127. Problem 11. A factory producing balls produces 3% defectives. Find the probability that at least 6 items are to be examined to get 3 defectives. Solution. Total number of defectives to be found is fixed as 3. Factory producing 3% defective balls. Hence, the probability of getting a defective bolt from the items produced P equal to 0.03. We know if Y is considered as the number of trials required for the rth success in a sequence of independent trials with two possible results, success and failure, where P and Q remain same for all the trials, P of y equal to small y, that is equal to y minus 1 C r minus 1, P raised to r into Q raised to y minus r, for y equal to r, r plus 1, r plus 2, etc. and equal to 0 otherwise. If y is considered as the number of trials required for the third defective, where P equal to 0.03, then y follows negative binomial distribution with PMF P of y equal to small y, that is equal to y minus 1 C 3 minus 1, 0.03 raised to 3 into 0.97 raised to y minus 3 for y equal to 3, 4, etc. and equal to 0 otherwise. Probability of at least 6 times are to be examined to get 3 defectives, that is equal to P of y greater than or equal to 6, that is equal to 1 minus P of y less than 6, that is equal to 1 minus of P of y equal to 3 plus P of y equal to 4 plus P of y equal to 5, that is equal to 1 minus of 3 minus 1 C 3 minus 1, 0.03 raised to 3 into 0.97 raised to 3 minus 3 plus 4 minus 1 C 3 minus 1, 0.03 raised to 3 into 0.97 raised to 4 minus 3 plus 5 minus 1 C 3 minus 1 into 0.03 cube into 0.97 raised to 5 minus 3, that is equal to 1 minus of 0.000027 plus 0.000079 plus 0.00015, that is equal to 1 minus 0.000256, that is equal to 0.999744. More problems arising in various real life situations involving two important discrete probability distributions, binomial distribution and negative binomial distribution, are discussed in this session. Application of these distributions can be best viewed through the problems discussed. Now, let us try to answer the following questions. 1. It is claimed that 70% of all biogas installations, the utility bill is reduced by at least 1/3. Out of 6 installations, find the probability that the utility bill is reduced by at least 1/3 in exactly 4 cases, at least in 4 cases. 2. The probability that the tire produced by a certain company lasts for 40,000 kilometers is 0.70. Out of 6 random samples of tires, find the probability that none, all, at least last for 40,000 kilometers. 3. An experiment succeeds twice as often as it fails. Find the probability that in next 8 trials, there is at least 5 successes. 4. If the probability of having male and female child is same, find the probability that in a family, the 6th child is the second boy. The books for your reference are Introduction to Probability Models, Sheldon M. Ross, Academic Press, 1997. Introduction to Mathematical Statistics, S. C. Gupta, V. K. Kapoor, Sultan Chand and Sons, 2003. A First Course in Probability, T. K. Chandra, D. Chatterjee, Narosa, 2003. A First Course in Probability, Sheldon M. Ross, Pearson Education, 2007. Probability and Statistics for Engineers, R. A. Johnson, PHI, 2005. And that was the end of this session. We will meet next time. Goodbye.